Hello and welcome to our CS 2316 final presentation on the correlation between housing, gas price, and inflation. To start, I'd like to give a little introduction to the team. My name is Juliana Manarelli and my partner is Tony Vo, and we are both third-year ISYE majors here at Georgia Tech. To give a little roadmap about what we're going to cover today, first we're going to start with introducing the topic of interest that we wanted to learn more about, and then our methods of data collection, and then going into our process of cleaning the data and manipulating it, and then visualizing the data, and then we'll finish up with the conclusion. Now for the topic of interest and our hypothesis. As consumers in the US economy, Tony and I have definitely noticed increased housing price, increased gas price, and just in general increase in prices of goods due to inflation. And it's no secret that this is in part at least due to the COVID-19 pandemic and the war in Ukraine, especially for gasoline prices. But we wanted to look into this even further and in a more technical way by studying it for this project. So our hypothesis is that there's a correlation between these three factors: house price, gas price, and inflation. And we believe that it's probably going to be a positive correlation in which if one of these increases, then the others will.
For data collection, since you are analyzing three different sectors, house price, gas price, and inflation, we had to use different datasets. The CSV dataset is an 11 megabyte file with more than 118,000 rows and 10 columns containing data for the house price index, or HPI. The first web requirement is the API from the Federal Reserve economic data. It doesn't look like a typical API, but has its own module embedded to extract the data I will be showing later. The second web requirement is an HTML file that has a table of 100 items for Consumer Price Index, or CPI. We also use extra sources including another HTML link, an API for 10-year expected inflation rate, and an Excel file for actual inflation rate that we'll be manipulating and analyzing everything together later. For data cleaning and manipulation, with the CSV file, we decided to break it out to smaller tables, which are the quality data for all 50 states and the quality data for all metropolitan cities in Georgia. We imported the CSV file and cut it to a list. Use list slicing to drop the last column with empty values, and we use the conditional statements to filter the relevant data, such as data between 1990 and 2022. The final result is a list of lists, and we exported the clean data to the corresponding tables. For the API, it actually looks very simple. We use the LSI function for thread database that can directly retrieve the data and return a pandas data frame, which is very convenient. And we dropped the real-time start column because it's irrelevant. And since there are a few empty values, we replace them with the word unavailable. The clean data frame is now exported to a CSV file. For the HTML link, we use the beautiful soup to grab the content in the link and basically recreate the same table. We pass through different tags. One is one level deeper than another until we reach to the tags that we wanted. The item names are in the th tags, and the named list is now a list of lists. Since the bracket is an empty list included in the bigger list, we iterate through the list and get rid of them. For the values for each item, they are in the td tags, and we did the same thing. Using the two lists we just passed through, we created a data frame and put everything together, exported to a new CSV file. The extra source, which is another HTML link, is also done using similar steps. For data analysis and visualization, starting with Insight 1, we are interested in the average house price in Georgia and in 50 states between 1990 and 2022, with a focus on COVID-19 period. We are using the two CSV files that we exported earlier during the phase 2 of data cleaning. We start by analyzing the data for Georgia. The first original dataset contains the data for all major cities in Georgia. To obtain the numbers for the entire state, we are aggregating by grouping all the cities by year and calculating the average for each year of all the cities in Georgia. This analysis is visualized by the blue light graph. Further, we use the diff accurate function to find the change in house price index of Georgia every year, which is the difference between the later year and the previous year. This analysis is visualized by the red bar graph. Similarly, we group all 50 states, including Georgia, by year and then use accurate function to find the average for all 50 states for each year. This analysis is visualized by the orange light graph. And this is our first visualization for Insight 1, using Matplotlib to create 3 different data graphs and condense them into one. We also use the legend function to include all of the annotations for better clarity. The blue line is for Georgia, the orange line is for all states, and the red bar graphs is for the changes in Georgia year by year. We can see that Georgia shows a very similar pattern as the national data. However, the changes in Georgia are not as significant. For example, during the 2008 depression, the drop in Georgia's dataset is not as steep as that of the US, and we can see that through the two slopes of the two lines. In addition, the number for the US is higher than Georgia's, indicating that the average house price index in Georgia still remains lower than the national average. From the red bar graph, we can see the negative bars, indicating decreases in price, and positive bars, indicating increases in price. Visually, the house prices in Georgia dropped during the 2008 depression and has been rising significantly since 2022, and the same thing for the US data. The tallest red bar is for 2021 with a value of almost 29. Note that some bars do not really show up because the difference is too small compared to the scale of the Y bar. In conclusion, this agrees with our hypothesis that there has been a rise in the house price index since COVID in Georgia and in all states in the US. And we will have a correlation with the other two topics we will be looking at, inflation and gas price, with the Ukraine war also in consideration.
For Insight 2, we wanted to compare the change in house price index over time, state by state. First, we used CSV Reader to read the data and then convert it to a list of lists. Then we iterated through the data, calculating the difference in HPI from 1990 to 2022, creating a dictionary with this difference as the value and the state abbreviation as the corresponding key. Then we used a list comprehension to convert this dictionary into a list of tuples and used a lambda function to sort the data by change in HPI in descending order, which means the state with the highest HPI is coming in first place. We then converted this data to the data frame shown here. We then plotted the states with the top 10 change in HPI in this bar graph. Geographically, we can tell states on the West Coast and East Coast are the main ones to experience spikes in house price index. As you can see, every change in HPI is positive, meaning HPI has been on the rise since 1990, which corroborates our hypothesis.
For Insight number 3, we are looking at the expected inflation rate and the actual inflation rate in the US regarding COVID-19 period and the Ukraine war. It's basically between January 2020 until now. And with the expected and actual columns side by side, we vectorize the two columns to find the difference between the expected and actual. And we also used masking and indexing to find the highest inflation rate and its corresponding date, which happens to be the newly released data, 9.1% for June 2022. And this is our second visualization for Insight number 3. We also used Matplotlib to create 3 different data graphs and condense them into one. And we also used Legend to show all of the annotations for better clarity. However, we had to reset the number of the ticks on the X bar because they would overlap each other. So we reset it to be numpy link space between 0 and 29 with a step of 10. We also reset the rotation to be 45 degrees. For the analysis, at the beginning of the pandemic, the actual inflation rate was mostly lower than expected. This is shown by the negative pink bars and the blue dots below the orange line. However, as the pandemic developed, the inflation has been getting worse and worse before reaching the highest of 9.1% in June 2022. Visually and statistically, the bar graph shows that the orange line, representing the actual inflation rate, is a lot higher than the blue scattered dots, representing the expected inflation rate. The same tendency can also be seen in the pink bars as they get higher and higher. This positively supports our hypothesis that due to unforeseen circumstances, like the COVID-19 pandemic and the Ukraine war, the inflation rate has been significantly higher than expected.
For Insight 4, we sought to find a correlation between house price index and gas price. To do this, we calculated the average HPI by year across all states because the gas data was national averages, not broken down into individual states. We then grouped the gas price data by year and performed the average aggregate. We plotted both data frames on the same graph using the TwinX method of matplotlib. Although the y-axes are different, they are comparable for correlational purposes because the HPI measures changes in house prices and gas price is simply the price of gas in US dollars. We then sorted both data frames and obtained the largest value for each respective quantity we were measuring. And it's worth noting that both the greatest HPI and gas price occur in 2022, which can help to imply a positive correlation between the variables. Here's our visualization, which was created using matplotlib, and it has two different y-axes, one with house price index and one with gas price, but both are graphed with time on the x-axis. And as you can see, just aside from that period between 2010 to 2015, the general trend is that there's a positive correlation between these two factors. And of course, post-pandemic and as well as in 2022 with the whole Ukraine war, we're seeing peak gas price and house price index. So they're both seeing a maximum, and in more recent history, there's definitely a positive correlation, which does follow our hypothesis. For Insight 5, we calculated the maximum and minimum CPI, which is Consumer Price Index, along with the corresponding items for the various timeframes throughout 2022. We first created a list from the column that represents all the goods and services in this CPI breakdown. We then iterated through the list of dates we are focusing on and calculated the min and max value of the CPI. We also converted the entire column to a list to be able to use the dot index method to locate the index of the min and max items. We applied this index to the list of items to obtain which item corresponded to the smallest and highest CPI for that respective time period. CPI measures the change in prices paid by American consumers for goods and services. The majority of the maximum CPIs for each time frame involve oil in some way. The fuel oil portion is self-explanatory, but airline fares, which is the highest CPI item for February to March 2022, also involves oil because jet fuel prices impact airline fares. So there also may be an increase in consumer prices in airline fares in this period as air travel is becoming more commonplace post-pandemic and COVID restrictions have lessened for travel. Now for the conclusion. In conclusion, there's a close correlation between house price, gas price, and inflation, especially in the times since the COVID pandemic and the Ukraine war. Insight 1 has taught us that economic measures to combat COVID have intensified the rise in housing price in the United States. Insight 2 has taught us that house prices have been seeing record increases, especially on the West Coast and in the Northeast coast of the United States. Insight 3 have taught us that impacts from COVID and the Ukraine war have caused the inflation rate in the US to reach its peak, which was 9.1% in June 2022. Insight 4 has taught us that gas price and house price are mostly positively correlated, with some exceptions. And Insight 5 has taught us that fuel oil and airline fare have skyrocketed due to the Ukrainian war. Thank you so much for your time, and we hope this has been informative.